Bonjour, Gatineau. Hello, guten Tag. Thanks to the organizers giving us the opportunity to talk as a relatively small company about equipment which allows the other organizations here to take stuff into space. So my presentation is talking about ground station antennas, and especially here related to the cooperation here with Canadian companies. So first of all, I want to give you a short overview of what we are doing here in Düspohl. So this is our facility. You see that we have not only offices, we have also a lot of integration halls, which are used to integrate here bigger pieces of the antennas. This only should show you that we are in total 70 people. Our focus is on technical issues. That means all what is needed to come up with a turnkey solution starting from scratch. So that means we have with us mainly engineers. We are in total 70 people. I have to take a look at this here. The area where we have the mechanical systems, the servo and drive and control systems, including monitoring and control. And we have a group here which is dealing with all RF equipment, radio frequency equipment. And it's clear that we have to have some services. I would like to mention only that we have installations all over the world. That means we have a staff of around about 10 people doing then the installation and the integration, and the engineers then will follow to do the acceptance testing. So what are our fields of activities? You see that we have products for satellite communications. We do some TT&C, IoT, and ranging. If you don't know what does it mean, TT&C is to steer the satellites at the exact location. IoT in orbit testing, and ranging is to move and control also here the position of the satellites. Earth observations, remote sensing, antennas for this application require full motion antennas. And then we have this area of these deep space missions, where we'll talk a little bit more about in detail. And one important area is the astronomy, that means telescopes. So the products, in general here, antennas, antennas, antennas. You see that these are here really simple ones. These are ones which are a little bit more complicated regarding here the performance. And if we are talking about ground stations, it's clear that more of the overall volume of a ground station is nowadays here with the RF equipment, control equipment, and what is ever needed to have at the end the possibility to receive and to transmit data from the ground to the space. SATCOM products include here simple antennas and also some electronics as LNAs, converters, and whatever. So services, I mentioned this already. I can proceed really quickly because we can start from scratch and we can end up with the acceptance testing on site. And at the end, customers are always requesting that we train their personnel so that they can take over then the antennas for the operational phase. This should show you that there is a strong development here to always antennas with more precision. And more precision means here that we have to think about improvements of the surface accuracy of these dishes, and also of the pointing and tracking accuracy. So we started here in the 17th with a 100-meter antenna when we were still a company in this bigger group, now this ThyssenKrupp family, with a 100-meter, and then you see various kinds of antennas with some unusual mountings here, and ending up here with antennas which are now here in the Atacama Desert. There we installed 25 12-meter dishes. So the question is always, can we get a step forward to improve the surface accuracy? Yes, we can. Is it possible to use conventional materials? No, we cannot. So that means we have to use nowadays carbon fiber reinforced plastics as backup structure, and to think about more precise control equipment to steer and point the antenna to the stars or to the deep space probes or whatever the task of the antenna is. So this gives you an impression, what does it mean to go to a site which is 5,000 meter altitude, where you see there's no green, nothing at all. And we have done a job here delivering 25 of these 12-meter radio telescopes, which can handle frequencies in the range up to terahertz. Terahertz, I say it again, that means 1,000 gigahertz. Communications nowadays goes up to 30 gigahertz. So these instruments are good here for using equipment which has to be developed by the scientists. This is not our problem. But we can deliver now these precision antennas. You will be wondering that I show this one, but this is used by the geodesy people, because these antennas, they provide accuracies of the location on Earth in the order of 1 millimeter. What does it good for? GPS, and in the future Galileo, they would like to have more precise information about the locations on Earth. And therefore they need these kind of antennas, and there's a big program which is called VLBI 2010. And all over the world now customers are asking for this precision antennas. So this is one site here in Belgium, here at Redux, it's Galileo again, a 20-meter antenna. And a totally different product is a kind of positioner, which allows you here to test within a big anechoic chamber, a compact test range, the functionality of a satellite. So such an instrument or such a positioner is capable of take loads up to 10 tons. So the next generation of satellites, what we hear, is in the order of around about 5 to 6 tons. And with some equipment on top of this positioner, it is designed to handle loads up to this 10 tons. So now Canada. We like to be in Canada. And we have a relationship which goes back here to the 80s. And always in the area of these ground stations for satellite communications. We have these deep space antennas developed here with a Canadian company. And recently we are also in a close contact with another Canadian organization regarding telescopes, antennas for a really, really big program, a worldwide big program. I will go to this in more detail. So, round about 30 years ago in the 80s, we started here a project here where MDA was the prime contractor, and this was for Kiruna Station for the European Space Agency. And MDA acts always as our customer, and as you understand, they are doing, I would say, the overall system design. They are manufacturer of the satellites, and then they are telling us what they need on the ground. It's not so easy that they are only telling us this here, but they will have a tender or whatever. We propose here our solutions, and then at the end we won. And the recent sample is that we have a program called Lubit, and this is here in the Ukraine, where we are responsible for the implementation of the ground station. Telesat. I think everybody is aware of Telesat because they are operating a big fleet of satellites. We have this relationship with Telesat Consulting Services, And Telesat has the relationship to the end users. And if a nation, for example, is asking for a complete new satellite system, then we are happy here that Telesat is aware of us, and sometimes they can convince also the end user that it would make sense to use as a ground station products here from Germany, from Vertex Antennentechnik. So the recent programs we realized were in Egypt, the ground station for the Nilesat program, and Telkom in Indonesia also used our antennas, which are looking just like these ones. The difference to the ones which I've shown before is these are all antennas which are used to cooperate and to receive and transmit signals to geostationary satellites. Satellite which is around about 50, 60 or 80 degrees far away, so that this is a kind of design which we call turning head, compared to really simple approaches where you have only a ground station capable of using one geostationary satellite only. So SED systems in Saskatoon. Mr. Skuka asked me, why are we here cooperating with SED in this case? The reason was that in the beginning of this deep space program of the European Space Agency, ESA allowed only prime contractors to show up from Italy and from Canada. And when we were invited to have these negotiations here or discussions here with the Italians and with the Canadians, it was an immediate decision that we should try to convince or to cooperate with the Canadians. And I say it was only a question of mentality and the kind how to deal with technical issues. So since that time, this relationship to SED ended up in contracts for the ground stations for ESA's deep space missions. So the prime contractor here is SED, the Canadian company. They take the responsibility for the RF equipment, which means amplifiers and converters, and also for the civil works. And we are then the supplier of the antenna, including the passive RF equipment, which mainly means the feed systems, and the servo and drive and control systems. And we do the turnkey installation at sites. You see on the left side, this is the first one, which is located in Australia. The site is operated here by ESA. The second one here, deep space antenna number 2. This is at Cebreros, close to Madrid. And since last year, operational is the third one. And this is the antenna located in Argentina at Malague. So now, NRC, National Research Council. And I mentioned here already that there is a worldwide program, and this is called SKA. And I think in this auditorium nobody have heard about it. SKA means Square Kilometer Array. This program will be financed by various nations all over the world. And the astronomers, they have a goal. They want to understand how the first stars and galaxies formed, how galaxies have evolved, and still they have no clue what is the role of magnetism in the cosmos, the nature of gravity, and the search for life beyond Earth. So what are they looking for? I mentioned SKA, Square Kilometer Array. And you can see if we would have antennas available with a diameter of around about 15 meters, this would require a total number of up to 5,000 units. 5,000 antennas with 15-meter diameter dishes. So, NRC, and we here from Germany, so the Canadians and the German, they are partners, in this SKA DISH consortium. And I say explicitly DISH consortium because the challenge or challenges of this SKA program are more in the fields of this big data handling. If you have so many antennas and they receive a lot of data, this requires then a completely new software, new data storage and everything. Then these antennas will be located, I would say, in an area which is close to or nearly a desert. And how can you use electrical power, or how can you produce electrical power in such an area? And we then are, let's say, asked here to provide dishes for an amount of money which can be afforded. So NRC is the leader of this antenna consortium, and we, in this first phase, are a consultant. And why? Because the Canadians, they have the clue and the know-how to fabricate a one-piece dish. It's a monolithic dish of a diameter of 15 meters. Monolithic material, in this case, is also CFRP, carbon reinforced plastics. The subreflector here has a diameter of around about 4 to 5 meters. And they have built the first prototype, and they will have the implementation of this DVA1 antenna. This is the design verification antenna number 1. This will be installed at Penticton, and I've been there and I've seen personally here how does it look like if you have a dish, one piece, 15 meters in diameter. Incredible. I could not believe it, but when I saw it, they made it. So we, as a consultant, we have the job in-house here to build the MERCAT project, the antennas for MERCAT. And MERCAT is a program of the South Africans. This is the forerunner of the SKA. 64 antennas of this design will be available in, I don't know, 2017 or whatever, in the Karoo area. And if you see that this and this concept are really similar, except that our antenna has a diameter of 13.5 meters, the DISH consortium was happy that we were willing to attend and participate in this consortium, having all design and fabrication documentation for this kind of antenna. So we are acting now as a consultant for this DISH consortium. That means we have this close relationship to NRC, and hopefully the money will be available, and there will be some progress regarding development of further antennas so that SKA in general will become alive. And this is an impression of the artists. If they see here that in Australia is enough space, so they can have there these 1,000 antennas, but the reality is that in the next phase, SKA believes to have 60 additional antennas in Australia and 190 in South Africa. So what could be the hardware which we could provide here for this SKA project? It's clear that some equipment here could come from Germany. Question is if it is affordable. So we are focusing here on, for example, on the control units and eventually on jack drives, which is a complete new approach with the direct drive, or eventually also some switch cabinets, but I think this is not realistic. To handle all this data, and you have this remote site, it's clear that you have to think about how you can control these antennas. So you need a centralized computer or whatever, and therefore we could provide, for example, also this monitoring and control system. So you see that this relationship here with the Canadian companies was a successful one, and having in mind that, for example, these recently mentioned programs indicate that it could be a long-lasting relationship, I think we would be happy if we can continue, and I hope that also the Canadians would be happy to continue with this kind of work. So thank you very much. If you have any questions, please let me know.
Thank you very much, Klaus. Are there any questions?
I'm just curious, are you in contact to the space agency of DLR, or you're acting completely independently?
Related to which space agency?
German one. DLR, German one.
We have installed a lot of antennas here in Germany, also for DLR, for example, at Weilheim. And just now we are talking to DLR about a new approach for remote sensing antennas, because everybody knows that frequencies will go up higher and higher. So presently it's clear that S and X band are the standard frequencies, and we are talking about DLR if it is feasible to have an antenna which can also handle in one antenna 3 bands, S, X and K. So we have a good relationship with DLR.
Okay. Well, as a provider of technology for the research part of DLR, do you get, maybe it's a stupid question here in the public, but do you get funding from the space agency of DLR?
No.
Okay.
No, we are a pure industrial company. All that what we are developing must be paid by our customers. And there is no R&D program where we are working in. It might happen that, for example, European Space Agency is willing to place a study with us to improve, for example, the surface accuracy of the deep space antennas.
Okay.
So that in future they can go also up to higher frequencies. And this will be the next phase, because communication also could be feasible using nearly optical communications. And there the next step will be to have on ground optical receivers which are not using as a surface material glass, but aluminum. Okay.
Good. I wonder if there's a question coming from the Gatineau side as well.
Yep, not at the moment.
I guess I'd like to ask one question, and I'm just wondering if you could, once you did establish your partnership with the Canadian company, what were some of the easy parts and what were some of the difficult parts of working with the Canadian colleagues?
I think the easiest part was here to come to an agreement in a really short time. And due to the fact that we have had no experience here, how they are working and how can we communicate. After, I would say, the first phase of this first deep space antenna, we were happy to see that there was no issue which could give us some concerns. So we are glad here, and I hope that we can have this cooperation also for the next deep space antennas which might be required here by European Space Agency. So there were no critical issues.
Great. Okay, well, thank you very much, Klaus. That was great. Thank you. Good.